Okay, so remember when we're finding the inverse of coordinates, so if we have x, y, the inverse of that is simply going to be yx. So we switch the x and y values of the coordinate. It's going to work the same or very similar feel when we're doing finding the inverse of functions or of equations. So our first step is going to be to switch the x and y values in the equation. And then because we always like to have y equals as our function, not x equals, we then want to solve for y. So those are our two steps. So for problem number 1, it's asking us to find the inverse of the following. And remember that if f of x is our original function, we could also see the inverse be written as f and then the -1 as the superscript. So that means the inverse of f of x. So just keep in mind that notation. I could just say like find f and then -1 of x. So that's what we're looking for. So for number 1, we're going to start by just switching our x and y values. So this would be x equals 3y minus 6. So step 1 is done. And then the next thing we want to do is solve for y. So we're going to add 6, we have x plus 6 equals 3y, and then we can divide by 3. So our final answer here is going to be y equals x plus 6 divided by 3, and we can just leave it just like that. For number 2, we have f of x equals the square root of x plus 3. You might want to just rewrite that. We know that instead of f of x, we can write y equals x plus 3. So far I've just rewritten our original function, but with a y equals instead of f of x equals. Then you're going to switch those to be x equals y plus 3. All right, so our first step here, we want to get rid of that square root, and we can do that by squaring this whole side, and what we do to the right side, of course, we have to do to the left. So that ends up with x squared, and then we've undone the square root with the square, so that's just y plus 3. All right, so then we're going to subtract 3 over, and then we end up with x squared minus 3 on the left, and then y on the right, so that's just y equals x squared minus 3, and that's our final answer there. Okay. Number 3 is, it starts to get a little bit harder, so you want to make sure you're paying attention, paying close attention to this. There's a little bit of a trick, so it works the same way, but you have to be a little bit creative algebraically. So for number 3, we start off with y equals x divided by x plus 1. So again, same process. You want to switch the variables. So you have x equals and then y over y plus 1. All right, so we have y in this rational expression. Right now, it looks kind of funky, but ultimately we want to get y by itself. So the first thing I would do here is multiply both sides by y plus 1 to get it out of the denominator. Another way you can think about that is cross multiplying. So this would be x times y plus 1, and this would just be 1 times y, which is y. We still have 2 y's, still some little bit of weird stuff going on. So next thing we want to do is distribute this x. So that gives us x times y plus 1 times x, which is x, equals y. All right, so the next thing we want to do, we have 2 terms with y, and so we want to get both of those to one side and everything else to the other side. So it doesn't matter which side. So I'm just going to subtract this term xy over. And we have x equals y minus xy. And note that these are not like terms, so we can't combine them. But what we can do is at this point we can factor out the y. So we have x equals and then y times 1 minus x. So we factored out the y, so now we just have something like a term equals y times something else. So for our last step, what we can do is we can get y by itself by dividing 1 minus x on both sides. This cancels out, and then we're just left with y equals x over 1 minus x as our inverse.